Hey everyone, it's Miss Lloyd, and we are going to be looking at 12.1 for my students, angles and degree measures. So this is the start of our chapter on triangle trigonometry. So we're going to be kind of diving into trig using triangles that we've learned about in geometry and in our past. So here today we're going to start with kind of just what are angles, what are degree measures, how do we find all of those things. And first off, we need to learn a little bit of the terminology. So standard position means that we're starting from the positive x-axis. So your initial side, whatever you're starting on, is going to start on the positive x. So if I have a coordinate plane, it's this red line right here, starts at the x-axis and then either opens up or opens down. So positive angles, they rotate counterclockwise, meaning that they're opening up from that initial side. So if I'm going from the initial side to my terminal side, going counterclockwise, it's a positive angle, a positive degree. And it's going to be negative if I'm going clockwise. So going from my initial to my terminal side the other way. So that's my negative angle. And then coterminal angles are angles that have the same terminal side. So typically they start at the same initial side. And so I know you're thinking, well, if they start at the same initial side and they have the same terminal side, doesn't that just mean that they're the same angle? But actually, they could rotate more than once, just keep going around. Like when you spin in a chair, you just keep spinning and spinning and spinning and spinning and spinning. It's kind of like that. So coterminal angles, they can start and finish on the same sides, but they could have a rotation to it. Also, there are different types of angles. So when we look at the coordinate plane, we have our first quadrant, our second quadrant, our third quadrant, and our fourth. So again, our initial side is always going to be starting on the positive x-axis. And so say we are looking at a second quadrant angle, that means that the terminal side is in the second quadrant somewhere. So my angle starts on this red and then opens up to the blue. So this is a second quadrant angle because that terminal side is in the second quadrant. So same situation if we have a first quadrant angle, that just means that I'm opening up again from my initial side, and I'm going to be opening up somewhere in the first quadrant. So this is a first quadrant angle because we're in the first quadrant here. And these labels of the quadrants are always going to be the same. We always start with double positives. So positive x and positive y is our first, and then it goes counterclockwise, second, third, and fourth. And then there's also a situation when we don't end up on or inside of a quadrant at all. Maybe we're on one of the lines, which means we're starting our initial side here. Maybe we end up exactly on one of the lines. So we're in between two quadrants. We're not in one or the other. So this is called a quadrantal angle. And this angle in particular is actually 270 degrees when we go straight down like this. So if you don't remember from geometry, up here would be our 90 degrees, 180 degrees, and then 0 or 360 degrees. They're the same, depending on if you haven't started or if you've gone all the way around. All right, so now that we've gone a little bit into some of the background, we can go to our first example where it talks about, it wants a formula for the measure of all the angles that are coterminal with 70-degree angles. And then they want us to use that formula to find the measures of 4 specific angles that are coterminal with a 70-degree angle. So we can find any of the angles that we want. So then here, I like to draw a picture. I'm a very visual person. So I have my y-axis, my x-axis. I'm not going to draw the entire coordinate because I know that 70 degrees is in between 0 and 90. So I'm just going to throw this up. I know that it's not actually 70 degrees. This is just my estimate since I'm freehanding. So here's about 70 degrees, my y and my x-axis. So I know I'm in the first quadrant. And so it's saying that it wants something that's coterminal with that angle, meaning that we have the same start and the same finish, but I don't have to just go to 70 and stop, so we could have gone all the way around into 70. So if I go an entire circle all the way around, so from the start back to the start again, that's 360 degrees. And then I ended up going that extra 70 degrees from there. So then that wounding angle that I just made in green is 430 degrees. And I don't have to stop after that first wound. I can keep wounding and wounding and wounding and wounding and wounding. I feel like that's not a word. I've said it so many times. But I can keep winding around. I don't have to just go that 360 degrees one time. I could keep going over and over again. So because I could keep going the 360 over and over and over again, I don't know how many times I'm really going to do it. I can use a variable for that. So x, or you could use another variable. It doesn't have to be x. I'm going to use x in this case, as x being the number of times that I'm going around from 70 degrees. And so this is the formula that I'm going to be using to figure out some of the other terms, or some of the other angles that are coterminal with 70 degrees. So I already found one of them with the 430 degrees by going 360 once. I could go 360 again, so I can multiply that by 2 plus 70, and I end up with 790 degrees. I don't have to just do positives either. I could do negatives, so 360 degrees and then times -1. So instead of going around the positive direction, this means that we're starting from our origin and going around the other direction. So I would have gone around and then stopped at this. So I still would have started here and then gone backwards to that 70. And then that would give me -290 degrees. And we can do that one more time because again we need 4. So I have 1, 2, 3. I just need one more. So I can plug in -2. Again, you can plug in anything. You can plug in 70. You can plug in 184. It really doesn't matter. I'm going to use simpler numbers. We end up with -650 degrees. And it's very important that we have that degree symbol because if we don't, then people will assume that it's radians. And that's something we're going to get into later, what radians are. But for now, we're just going to focus on degrees. And we want to make sure that we have that degree symbol in our final answer so that we know that it is degrees that we're talking about, not something else. So we've got our formula and our 4 solutions. All right, so this next bit, whenever it comes to sailing or anything like that, sometimes an exact degree from a heading doesn't get you in the place you really need to go. This is a really big planet. 1 degree the degrees of separation are miles and miles and miles. So in order to account for that, there's also minutes and seconds. And the minutes and seconds work exactly the way hours, minutes and seconds work. So you could think of it kind of like hours. It works the same way to get from hours to minutes, minutes to seconds, and then back the other way. So then here, whenever they want us to express this first one, this is technically 64 degrees and 9 minutes. They want me to put it in as a decimal. So that means that I need to change this 9 minutes and figure out what's the decimal out of hours it's going to be. So I have this 64, I already know. And then in order to get from minutes to hours, or minutes to degrees in this case, I'm going to be dividing by 60 because I know there's 60 minutes for every hour. So I want to break up that 9 minutes and figure out how many hours it's going to be. So I'm dividing that 9 by 60 to figure out our decimal. And we would end up with 0.5. I'm sorry, 0.15. So that's now our degrees. So my final answer is just 64.15 degrees. The same, pretty much the exact same way that you're going from hours to minutes to seconds, you're doing the same thing for this. The next one, they give me the decimal and they want me to put it in degrees, minutes, and seconds. Do these in a few different colors to make it a little bit easier. So this is like saying we have 53 hours. I'm going to say degrees because it's in degrees, not technically hours, even though it works the same way. And I need to figure out how to turn that decimal, the 0.721 of those hours, and figure out how many minutes it is. So whenever we're doing that, this means that we're going to be multiplying. So I'm going to be doing the 0.2721. And I'm going to multiply that by 60 in order to figure out how many minutes, full minutes, were in that hour. And now I've got still that 53 degrees. And then when I multiply the 0.721 by 60, I end up with 43.26, and this is minutes. Again, it wants degrees, minutes, and seconds. So I should probably put this in the blue. It wants degrees, minutes, and seconds, which means I'm going to take that decimal here of minutes, and I'm going to figure out how many seconds that is. Again, there's 60 seconds in a minute, so I'm going to multiply this by another 60. So now I have 53 degrees, 43 minutes, and then the 26 times 60 is 15.6 seconds, but it doesn't want a decimal in seconds either, so what we're going to do is we're going to round to the nearest second. So this is going to be 16 seconds. And then we're done. So again, it's just like hours, minutes, and seconds, just instead of hours, we're using degrees, but they work the same way. All right, next bit, they want us to sketch the angle in standard position. So again, standard position means that we're starting on that positive X. They want to indicate the rotation by a curved arrow. So they want us to show the direction that we're going from standard position, depending on if it's positive or negative, and then classify the angle by its quadrant. And so if it's quadrantal, so if it ends up on one of the axes, then we just have to say it's quadrantal. So then here 210, so I know again that we have 90 degrees here, 180 there, 270 here. So I know that it's going to be somewhere in the third quadrant because 210 is in between 180 and 170. So we would end up approximately, it's closer to 180 than it is to 270, so I'm going to show that. It's positive, so I know I'm going counterclockwise. So this is my 210 degrees. And then this is because we end up in the third quadrant, this is a third quadrant angle. And then we're done. Our next one, this one's negative. So I'm starting again at standard position. And because it's negative, that means that I'm going the opposite direction. So I'm going to be going clockwise. So going clockwise, this would be negative 90 degrees. Again, just that one shift of a quadrant is 90 degrees. Because we're going the opposite direction, it's negative. And then this would end up being negative 180. So then I can draw my conclusion and then my curved arrow. So because this is on the negative x-axis, this is going to be a quadrantal. And that's it. Not too crazy. So again, we're just kind of introducing ourselves to these angles and getting to know them a little bit better. Shouldn't be something that's crazy difficult. This next bit wants us to sketch in standard position the angle that is 1/3 of a clockwise rotation, and then find the measure of that angle. And it also says it's in standard position. So I'm going to, again, start on standard position. 1/3 of the way, I'm going to find the angle, the measurement of the angle before I actually do the 1/3 because like the visual of the 1/3 is just, it's not something I can do, which is weird because I'm a visual learner. So I don't know, it just doesn't click for me. I always get made fun of whenever I have to cut like a pie or something. So then if it's 1/3, I know an entire rotation is 360 degrees. So 1/3 of an entire rotation, I'm going to do 1/3 times the 360, which will give me 120. Because it says it's clockwise, I know this is going to be negative because clockwise, we're going in the opposite rotation. Sure, that rotation. So I know that it's going to be negative. And then I know before we had negative 90 degrees here if we're going the opposite directions, and then negative 180 degrees there. And so I know that it's going to be somewhere in the third quadrant. And we're going to be about here. Again, we want to show that rotation. This is a negative 120 degrees. So it asked for the measure of the angle and to sketch it. We've done both of those. So we're ready for the next. All right, and these, I believe, are our last two. So they've given us an equation on how to find these different angles, and then they've given us different values of n to plug in to figure out what those angles are. So this could be different every time. This is just the equation that they gave us. It's not necessarily an equation that's going to be the same every single time. So if I'm plugging in 1, that means I'm doing 90 plus 180, which will give me 270 degrees. This is all positive. So again, I'm starting in standard position. And then 270 degrees is straight down because we have 90 and 180. So then this down here is our 270. And that's it. So we just sketch, give the value, and that's it. We're done. Next one, we're plugging in negative 1. So 90 degrees minus 180 would give me negative 90 degrees. So again, starting at standard position, negative 90 degrees means I'm going in a counter or a clockwise rotation. So that means I'm just going straight down here. This is my negative 90 degrees. And that's it, we're finished. So if you're one of my students, you can find your homework on the LMS page. If you are not one of my students, or even if you are, you can like and subscribe, send this, share it to anyone who you think might need it. Spread the love. Hope you guys are safe and well out there.